So here we go. I'm a little bit late getting this posted. Sorry about that. So the idea today, we're looking at moving on from simple stoichiometry into what we call two-step and three-step stoichiometry. Stoichiometry itself is literally looking at quantities of materials inside of a reaction. So we're looking at balanced chemical equations, we're looking at multiple ratios, all of the things that go with that. So again, simple stoichiometry is what we've already done up until this point. It's only looking at moles of one thing to moles of another. So in the reaction that we did the other day, you looked at a video with me. Here's another sample. How many moles of aluminum oxide are required to produce 6.2 moles of oxygen in this decomposition? So we don't have a balanced equation. That's the first thing for every single one of these problems that you should ever be able to do. You have to balance the equation. So I have 3 oxygens over here, but only 2 oxygens over here, which means I need to put a 3 in front of that and a 2 in front of that to balance the oxygens. But now I have 4 aluminums. Well, that's easy enough with a 4 there. This is the balanced chemical equation, right? 2 aluminum oxides, 4 aluminums, 3 oxygens. That's the easiest, simplest way we can reduce this down with whole numbers. So at this point, if I wanted to know how many moles of this is required to make 6.2 of this, my recommendation to you is when you do these, label moles underneath that sample. And again, you're not going to be able to do these in your head, especially as we start to get to 3 and 4 step stoichiometry, not 4 steps, sorry, 2 and 3 step stoichiometry. You're going to need to do these on paper. So for this, I'm going to write underneath this thing that I know 6.2 moles of this. I'm going to write it underneath that sample. And I want to know how many moles of Al2O3 are required. So this is my unknown, like we can call that X, right? So the mole to mole ratio is for every 3 oxygens, I will need to have dissolved or decomposed, whatever the term is you want to use. I need to break apart 2 of these to make 3 of those. If this had been 4, this would be 6. Oh, look, it's like 6 point something, which means it's going to be a little bit less than that over here. Sorry, a little bit more. Gosh, that was bad. Hope that didn't confuse you too much. For every 2 of these, I need 3 of those. If I'm making 3 of these, I need 2 of those. This ratio is not that difficult. So I'm just going to extend this down a little bit so we have more room. What we need to do is I use the dimensional analysis tracks like we've been talking about before. This is what I know I'm starting with. I'm writing down my 6.2 moles of oxygen. From here, I'm going to use the balanced equation. For every 3 moles of oxygen, this is what I have. So the ratio of this is like 3 is to 2 as 6.2 is to X. But the easiest way to rearrange that equation to solve for the missing variable is I'm going to divide by this one and multiply by that one. So the 2 moles of Al2O3 goes on that side. So all I have to do to solve this problem is I take the 6.2 times 2 divided by 3, and you should get an answer of 4.13 moles of that stuff, Al2O3. Okay? This is a simple stoichiometry problem because there's really one step, and it's using this balanced equation as a ratio. If you don't like that, if you remember algebra expressions and you remember ratios that way, then do that way. 3 is to 2 as 6.2 is to X, and do an algebra problem. This is the chemistry stoichiometry way of looking at this as dimensional analysis. All right? Let's do another one, but now let's move into what we call two-step stoichiometry. Now in 2 steps, something else is going to happen. It's going to require you to convert from either grams to moles or moles to grams throughout this process. But only one of those is going to need to be done. So the problem that we gave here, we're going to do it on the next slide, is how many grams of aluminum oxide, how many grams of aluminum oxide are needed to produce 9.5 moles of O2. So let's identify what we know and go from there. So this is what we're trying to solve for, right? How many grams? This is our unknown. And what we know is we are producing this is given, right? We're given 9.5 moles of oxygen. It's the same reaction that we just did, but now we're going to look at it from a different standpoint because instead of moles, now we have this thing grams, which is why in the last unit it was so important to know how to convert between grams to moles and moles to grams. So here we go. Here's our equation again. Don't worry about this down here in the bottom. That's going to be our next problem. So let's do this even. All right, so again, we don't have a balanced equation. I need a 2 here, I need a 4 here, I need a 3 there. There's our balanced equation. And now for these, write what you know on the balanced equation. I know from the previous problem, do you remember what it said? Because I do. It said we want to know how many grams of this are required. I'm going to put grams above the sample. And to make moles, we had 9.5 moles of oxygen. All right, let's go back to make sure, because I know that some of you are forgetting already. 9.5 moles of oxygen. How many grams of aluminum oxide? All right, so moles of oxygen was 9.5. We want to know how many grams. There is no way for me to do this problem in one step, because there is no relationship between moles of this and grams of that. The balanced equation is only a relationship between moles. I can only go from moles of one thing to moles of another. So this 9.5 moles, I can figure out how many moles of this is going to be. So it's going to look like this. I'll even change colors now. We'll go 9.5 moles of oxygen, right? And we want to convert this into moles of aluminum oxide, because the only way I can get to grams is if I know how many moles this is. So I'm going to take this ratio that we just did in the previous problem. 3 moles of O2 makes 2 moles of Al2O3. That converts us out of moles of oxygen. Multiply by 2, divide by 3. I have moles of aluminum oxide. This step took us from here, and now we're sitting here at moles of this stuff. And now I have another problem I have to do. I have to convert from moles of aluminum oxide back to grams. So now I don't care about this 2 being here anymore. What is the molar mass of aluminum oxide? So 1 mole of Al2O3 is what's going to go in that spot. We need to then look at the periodic table. We're going to add up our substances, 26.98 times 2, plus 3 oxygens, which is 48 each. Our molar mass is, let me make sure I did that right, 26.98 times 2, plus 3 oxygens, 101.96. That is how many grams of aluminum oxide are in 1 mole. So if I converted this from here to here, 9.5 times 2 divided by 3, so whatever 19 divided by 3 is, it's not a whole number. So let's see, 9.5 times 2 divided by 3 gives me 6.33, right? So that 6.33 is moles of aluminum oxide. I don't care about moles. I want to know how many grams it is. So now I multiply that value times the 101.96, and I round it to 3 significant figures, and I get 646 grams of aluminum oxide are required. This is a 2-step stoichiometry problem because I had to do 2 mathematical calculations beyond finding the molar mass. So remember, we still had to find the molar mass, right? I had to do this problem before I could finish this thing up. Let's look at this other sample I have here on the board. How many moles of hydrogen will be produced when 20 grams of aluminum is dropped into hydrochloric acid? So again, in order to do this problem, I have to balance the equation first. So I have aluminum on both sides, we're good. I have 1 hydrogen and 1, oh no, 2 hydrogens. Let's make sure. We want to save hydrogen for last if we can avoid it. 1 chlorine, 3 chlorines. So that's a problem too, isn't it? If I fix the chlorine with a 3, that messes up the hydrogens even worse. So do you see that the first time 3 H's and 2 H's is going to be at 6? That's the first time they become balanced. So we're going to go over here, make this a 6, make this a 3. That balances the hydrogens. I now have 6 chlorines, which means I need 6 chlorines. Those 3 times that 2. I got 2 aluminums. I need a 2 there. There's my balanced equation. But now I want to know how many moles of hydrogen will be made. So we're looking here. I want to know how many moles of that stuff can be made from 20 grams of aluminum. So I'm going to label that above what I know. 20 grams of aluminum will go there. I have 2 steps that I have to take. I have to convert this grams into moles by dividing by the molar mass of aluminum, and then I will convert that number of moles to this number of moles using the balanced chemical equation. So again, we'll extend this down so we have space to write. So we're going to start with what we know. We know 20 grams of aluminum. And we're going to do 2 calculations, 2 steps. The first one, 1 mole of aluminum on the periodic table is 26.98 grams of aluminum. That step converts us from grams into moles. Then I can use the mole to mole ratio to determine how many moles of aluminum are going to make moles of hydrogen. For every 2 aluminums, I'm going to make 3 hydrogens. So 2 moles of Al goes on the bottom, 3 moles of H2 goes on the top. And now I just do simple algebra. 20 times 1 divided by 26.98 times 3 divided by 2. I've got a calculator right here. 20 times 1, 20 divided by 26.98 times 3 divided by 2, and I get 1.11. And this is now moles of hydrogen gas. So now, does it make sense? If 20 grams is a little bit less than 1 of these, right? This is 1 mole, 26.98. I have a little bit less than 1. 2 is supposed to make 3. 1 would make 1.5. I have less than 1. I should make less than 1.5. Good. My value actually makes sense. This is a 2-step stoichiometry problem. Hopefully you're starting to realize that it's all about balancing the equation and using that mole to mole ratio. That is the only thing that's new here. You know how to convert from grams to moles. You know how to convert from moles to grams. Where this becomes more difficult is now we're going to move to a 3-step stoichiometry problem. In 3-step stoichiometry problems, we're going to start with grams of something and find grams of something else. So the reaction that I have written here for us to work on, I'll have again on the next page. I already balanced it and everything. Is how many grams of calcium carbonate will be precipitated if 40 grams of calcium chloride is dissolved in water and then mixed with sodium carbonate. So if you remember when we did a couple of these experiments, we actually did this in one of our labs the other day. The calcium chloride and sodium carbonate, when they get mixed together, gets cloudy because this calcium carbonate, which is off my screen, sorry, let me fix that real quick. That stuff is insoluble in water, and so we can't do anything with it. It's like a solid. It makes this stuff cloudy. So again, 40 grams of calcium chloride, and we want to know how many grams of calcium carbonate we're going to make. So on this next screen, I've already labeled stuff that we're looking for. We're given 40 grams, and I want to know how many grams of calcium carbonate. Before we even start this stoichiometry part, there's another part that you have to be aware of, and that's finding the molar masses. So we're going to do that first before we even move on, because if you don't have the molar mass, it makes this problem even harder. You're like, I think I know what I'm doing. What do I do? So calcium chloride. Calcium, I forgot to change. Calcium is 40.08. Each chlorine is 35.45, so that's going to be 70.90. The molar mass of this is 110.98 grams per mole. That's the molar mass of calcium chloride. This is a separate side problem before you can start. One of the reasons high school students hate chemistry is because there's so much work to do. It's like, oh my gosh, it's like, you say it's 3 steps, but it's really like 6. You're right, because there's other things that you have to be able to do, which is why I've told you from the beginning of the year, it's not one little thing and I'm done and I said it, throw it away. Chemistry builds on itself, and you have to remember all these things we've done all year. I don't care about sodium carbonate. I don't care about sodium chloride. I do care about calcium carbonate. I need to know the molar mass of CaCO3. Well, again, calcium is still 40.08. Carbon is 12.01. And now there's 3 oxygens, which is 48.00. When you add these together, you get 100.09 grams per mole for calcium carbonate. Notice that these molar masses are not that far apart. So just off of the simple understanding of what's happening here, this is 111, this is 100. Our answer should just be a little bit less than 40 grams when we get done. But you cannot compare grams to grams. The relationship in this balanced equation is not a gram relationship. So let's write that. This is not grams relationships. Okay? They're not related in grams. They're only related in moles. So in order to do this problem, again, we'll change colors one more time back to red. I'm starting with 40 grams. 40 grams of CaCl2. And from there, I need to do 3 steps to convert from grams. I'm going to go grams to moles of calcium chloride. That's the first step. Then I'm going to take this and convert to moles of calcium carbonate. which is a 1-to-1 ratio. So however many moles of this we've started with, that's how many moles of this we're going to make. And then once I have that number of moles, I'll do another step to convert it back to grams. So again, 40 grams of CaCl2. I know that 1 mole of this is 110.98 grams. So that's my first step. I took this number and divided by that. Now the mole to mole ratio is 1 mole of, 1 mole of CaCl2 makes 1 mole of CaCO3. It's a 1-to-1 ratio. Nothing happens except this was CaCl2. Now those moles of calcium chloride cancel. Those grams canceled over there. I now know how many moles of calcium carbonate I would need. And the last step is to multiply by that molar mass of calcium carbonate. Okay? So again, 40 times 110.98. Sorry, not times. 40 divided by 110.98 times 1 divided by 1 times 100.09. And remember I told you the answer shouldn't be too far off. It's 36.1 grams. 36.1 grams of calcium carbonate. So again, as we look at these problems, 3-step stoichiometry sounds like it's going to be really hard. If you know how to find molar mass and you understand this mole to mole ratio, this is a 1-to-1 ratio. If we'd been trying to solve for sodium chloride instead, we would have had to multiply this by 2. Don't get overwhelmed by this. We will continue to do more sample problems. I'll give you a couple things to do in class. But tomorrow in the lab that we're going to do, you're going to be doing measurements of chemicals in order to determine the number of moles that you've got. It is literally going back to review grams to moles and moles to grams, but you're actually going to be measuring them out. It is imperative that you use proper precision in your measurements, and it's imperative that you follow the instructions that have been given to you. Each of the groups that is going to be working on this will be given different values and different substances, and thus, it's all the same substances, but you're going to have different values that you're supposed to be measuring out. So if you just say, hey, what did you get? That's not how it's going to work. You will then take your substances that you've measured out, you are going to bring them to me at the front table, and I'm going to check and see how well you did on your measurements and your calculations, and you'll get a grade based upon that. This is an accuracy grade, not just that you got it done. And it's all going to be taken care of in class on Friday, in class, and you'll be done. All right? So again, stoichiometry, simple stoichiometry is just moles to moles. That should be the easy part. Simple stoichiometry is only moles to moles. 2-step stoichiometry converts either grams to moles or moles to grams somewhere in there, and you still use the mole to mole ratio. And the third one being 3-step stoichiometry, you're going to be given grams of one thing, trying to find grams of something else. You've got to convert grams to moles, then you use the mole to mole ratio, and then you go moles back to grams. And it's like we're doing a little dance. It's a 3-step dance. Grams to moles, moles to moles, moles to grams. 3-step stoichiometry. Hope this helped a little bit. We'll continue to work on more assignments together, both in class and for homework. I'll give you a couple practice problems in class, and we'll make sure you get this next week. Thanks again. We'll see you soon.